So let's look into the next component of Hadoop, that is the MapReduce. MapReduce is a processing framework and a programming model used in Hadoop to process and analyze large dataset in parallel across a cluster of computers. It simplifies the task of distributed data processing by breaking it into two main steps, that is the map phase and reduce phase. Let's look into the map reduce phases. So in map phase, what happens is the input data is divided into smaller chunks, and each chunk is processed independently by multiple worker nodes. These worker nodes are called mappers, and these mappers use a map function called map function uh, that processes input data chunks. And the map function transforms the given input data chunks into a set of key value pairs. Next up is the shuffle and sort phase. After the map phase, the output of the map phase is a set of key value pairs. These shuffle and sort phase will combine the group all the same key values into one group. So it basically shuffles the data and sort it based on the key, and it will group it. So now we have a group of from a output of map phase, which was a set of key value pairs. Now we have an the shuffle and sort will take these set of key value pairs, and based on the key it will group all the same keys together. So now let's look into combiner and partitioner. Combiner and partitioner are integral component of MapReduce framework shuffle and sort phase, which occurs after the mapper phase and before the reducer phase. The combiner is an optional component of MapReduce that operates on the output of the mapper phase. The primary purpose of combiner is to perform local aggregation and reduce the amount of data that needs to be transformed across the network during the shuffle and sort phase. So basically what happens now, for example, we have the map phase, and the map phase has given the set of key value pairs. Now in shuffle and sort phase, what will happen, these shuffle and we will try to group the data again, right? So this grouping will involve network transfer. So from one data node, the data will go to another data node to while grouping. So in order to reduce this lot of network interactions, we use the combiner, which will do another local aggregation, and reduce the network transfers, and it is also known as a mini reducer. Next, the partitioner is responsible for determining which reducer a particular intermediate key value pair is sent to after the map phase. Next, after map phase and shuffle and sort, then we have the last phase, that is the reducer phase, or that is the reduce phase. In this phase, the group data from a map reduce phase is further processed. The worker node in this phase called reducers apply a function called reduce functions. Then the reduce function performs some operation on the group data, usually involving aggregation and computation to produce the final output. Okay, now let's look into the architecture of MapReduce. So in MapReduce, when the client, we have a client who will be the responsible for submitting any MapReduce job. So MapReduce process begins with the client who submits the MapReduce job to the Hadoop cluster. The job will include the input data, the map function, reduce function, and other configuration if needed. So when the client will submit the data to HDFS, which will be taken job tracker, that is also known as a control node, is the central control node that coordinates and manages the execution of MapReduce job. So the client who submits the MapReduce job is received by a job tracker, which is running in the name node of a Hadoop cluster. It divides the job into multiple tasks and assigns the tasks to available worker nodes and monitors the progress. So each of these worker node will run the task tracker daemons. Each of these worker node which runs a task tracker will receive the task. The task include map phase and reduce phase. Red- so these the worker node will run the daemon called task trackers. The task tracker will run the task which will have the map task and reduce task. The task tracker communicates with job tracker to report the progress and status. Map. So again, let's look in the entire flow. So we have the map task. During the map task, the input data is divided into splits, and each split is processed by a separate map task. The output of the map task is an intermediate key value pair, and the shuffle and sort. After the map phase, the framework performs a shuffle and sort operation to group the key value pairs by key. This is essential for efficient data transfer to the reduce task. The reduce task takes the grouped key value pair process and then processes it by reduce task. Each reduce task handle a specific key and and its associated value. The reduce task apply the reduce function to produce the final output. Now let's take an example. So basically, it is more good to understand based on an example. Let us understand you have a text file which has some sentences, some words, paragraph, and you want to count occurrence of each word in that text file. And so you will give the data to the client will submit the file. You will submit the reduce function and map function and reduce function. Uh, Map functions, and what will be the responsibility of map function. The function will uh, so the client when the client is submitting, he will submit the data map function and reducer function, and once the job tracker will take this input, and it will split the data and provide this map function and reduce function across the worker nodes. And the worker nodes, for example, each worker node will get a particular line from the from the text file, and these will count the map function which we have written will basically count each word and assign its value. So key, for example, the key will be the and value is 1. So for example, mapper 1 will emit this and mapper 2 will give this output. Next, after this, the shuffle and sort will try to group all the same key values into one. So this will be grouped. We will have a grouped key value pair, and now this will be given to a reduce phase which is again running in the worker node, and these the reduce task will run the reduce function. So reduce function we might have written to group the values, mm, to find the occurrence. So for example, the quick, we had two values, two time it occurred, so it will give 2. The final output of the reduce function phase will be the word count program will be like this. So in MapReduce framework, the responsibility of splitting the data, input data, and assigning those splits to different worker node falls on the Hadoop system itself. Now let's look into the advantages of MapReduce. So parallel processing. So once we give the data and map function and reduce function, the data is split into multiple blocks, and these blocks are given into multiple worker node, and on multiple worker node at the same time the map function and reduce functions are running, so everything is running on parallel. Fault tolerance. So the framework handles task failure automatically by reassigning the task to other available node. Scalability. As the data size it grows, you can scale the cluster by adding more nodes, enabling the processing of larger dataset. So this is how MapReduce works.